Today we're going to discuss solving systems of linear equations using the elimination method. So let's get started. There are three main ways of solving systems of linear equations. There's the graphing method, where we graph the lines and see how they interact with each other. And then we have two algebraic methods, the substitution method and the elimination method. Now with both of these algebraic methods, the goal is to temporarily eliminate one of the variables. Because of this, the substitution method is sometimes called elimination by substitution, and then the elimination method is called elimination by addition. Today we're going to look more closely at this elimination by addition. With elimination by addition, we're going to use the addition property of equality, which states that adding the same number to both sides of an equation keeps the equality. So for any real numbers a, b, and c, if a is equal to b, then a plus c is still equal to b plus c. Using arithmetic, this would be like having the equation 2 plus 5 equal to 7. We could add 4 to both sides of this equation. So we're adding the same number to both sides. Simplifying both sides down, we end up with 11 equal to 11. We kept equality. Now, this may not seem very practical, but we use addition property of equality when we solve equations like x minus 7 equal to 3. The first step here, well, sometimes we can say we're going to undo the subtraction by adding 7. Well, what we're doing is we're adding 7 to both sides of this equation. For this equation, these two sides are still equal to each other. Simplifying down the sides, we end up with our solution, x equal to 10. Now let's see how we're going to use this property to solve a system of linear equations. So here we have a system of linear equations. We have two linear equations, x plus y equal to 8, x minus y equal to 4. And we want to find the values for x and y that make both of these equations true. So let's look at this in terms of this property. So if we look at this first equation, we can say that this left side, x plus y, well, that's a, and the right side is b. So we have a equal to b. That is x plus y equal to 8. Now I chose the first equation, but you could have chose the second equation. And in this case, x minus y would have been a, and 4 would be b. So our a equal to b would be x minus y equal to 4. Either method works, so I'm just going to stick using this first equation. So for this property, we have the a equal to b part. Well, how about the c? Well, looking at this second equation, well, we could say that 4 is c. So if we set c equal to 4, then we're going to add 4 to both sides of this equation. And that works, that's valid, but it doesn't really get us anywhere. But what we can do, well, if c is equal to 4, and 4 is equal to x minus y, because the left side of this equation is equal to the right side of this equation, if the right side is c, well, that means the left side is also c. X minus y is the same thing as 4. So now to one side of the equation, we could add x minus y, and to the other side, we could add 4. Rewriting this, we get x plus y, that's our original a, plus x minus y, that's one way of writing c, equal to 8. So 8 was our original b, plus 4, which is the same as x minus y. So let's simplify down each side. We'll have x plus y. We can remove these parentheses. So x minus y equal to 12. Combining like terms, we get 2x. Then we have plus y minus y. So that's 0y. So we have plus 0y equal to 12. 0 times y is 0. So we end up with 2x equal to 12. Dividing both sides by 2, we have x equal to 6. So we have found the value for x, and we can plug this value into either of these two equations to find y. I'll go ahead and plug it into this first equation. So we have x plus y equal to 8. So this is 6 plus y equal to 8. Subtracting 6 from both sides. This gives us y equal to 2. So the answer is the ordered pair 6, 2. We can quickly check this. X plus y, 6 plus 2, is equal to 8. And x minus y, 6 minus 2, is equal to 4. So let's look at the steps that we're going to use to solve systems of linear equations using elimination. So the first step is going to be to write both equations in standard form. So ax plus by equal to c. We'll discuss step 2 in the next lesson. In the examples we look at today, we're not going to need step 2. With step 3, we're going to add the two equations. When we add these equations, we'll create one equation with one variable. And we're going to solve that new equation. So we've solved for one variable, and then we'll find the value of the other variable by substitution. And as is always the case, check your answer when you're done. So let's practice a few. We're going to solve the following system by elimination. We have x minus y equal to 11 and 2x plus y equal to 16. So the first step is to write both equations in standard form. Both of these equations are in standard form. The next step is to add the two equations, creating one equation with one variable. So when we add these equations, we're going to add the two left sides. So we have x minus y. That's the first equation plus the second equation, 2x plus y. And then that's equal to, well, the first equation's 11. The second equation is 16. This is one way of adding these two equations. In a sense, we're adding these horizontally, much as if we wrote this as 5 plus 11 equal to 16. You may have done this when you were learning arithmetic, but you also may have lined it up vertically like this. You had 5 plus 11, and that's equal to 16. It's another way of writing this same addition step. Well, we can do the same thing here. We have our x terms lined up and our y terms lined up. Here's our equal sign. And then here's the constant. These are all lined up. We're going to add these. So I'm going to draw a line underneath here. Put my little addition sign. And then we can add. So x plus 2x is 3x. Negative y plus y, that's 0. So 3x plus 0, or 0y if we want to, is equal to 27. So we would have gotten the same value if we did it horizontally. So let's combine our like terms. We have x plus 2x. So this is 3x. And then negative y plus y. Once again, we have plus 0 or plus 0y equal to 11 plus 16 is 27. So these are the same equations. And how you do this step is up to you. I prefer this method. I see everything lined up. It also works well with step 2, that step we haven't discussed yet. But either way works. But I'll continue with this vertical method. So 0 times anything is 0. So we have 3x plus 0. So that's 3x equal to 27. Then solving for x, we're going to divide by 3. We end up with x equal to 9. And then we can take this value for 9 and plug it back into either of these equations. So I'm going to go ahead and plug it into this first equation. So we have x minus y equal to 11. That means 9 minus y equal to 11. Then we're going to subtract 9 from both sides. We're adding a negative 9 to both sides. We now have negative y equal to 2. And then dividing by negative 1, or multiplying by negative 1, we end up with y equal to negative 2. So our solution is the ordered pair 9, negative 2. Let's go ahead and check that value by plugging it back into both equations. So with this first equation, we have x minus y equal to 11. So that is 9 minus a negative 2 equal to 11. That becomes 9 plus 2 equal to 11, and 11 equal to 11, so that's true. With the second equation, we have 2x plus y equal to 16. So 2 times 9 plus a negative 2 equal to 16. 18 minus 2 equal to 16. 16 equal to 16. And that's also a true statement. So the solution is the ordered pair 9, negative 2. So this is where, if we graph the lines of those two equations, this is where those lines cross. It's the one point they have in common. Let's look at one more problem. So we're going to solve the following system by elimination. So we have the equation 4x plus 8y equal to 24, and negative 4x plus 2y equal to 6. First step is to write both equations in standard form. We already have that. Skip in step 2. And now we're going to add those two equations to create one equation with one variable. You can go ahead and add both of these equations. So 4x plus a negative 4x, well, that's 0x plus 10y equal to 30. So we have 10y equal to 30. Dividing both sides by 10, we end up with y equal to 3. And then we're going to plug this y value back into either of those equations. I'm going to go ahead and pick the first equation again. So we have 4x plus 8y equal to 24. So wherever there is a y, we'll replace it with a 3. So we have 8 times 3 equal to 24. This is 4x plus 24 equal to 24. Subtracting 24 from both sides, we end up with 4x equal to 0. And then dividing both sides by 4, we have x equal to 0. This gives us the ordered pair 0, 3. As the solution for this system. So checking that answer, we'll have 4x plus 8y equal to 24. This is 4 times 0 plus 8 times 3 equal to 24. So 0 plus 24 equal to 24. We end up with 24 equal to 24. That's good. Then with the second equation, we have negative 4x plus 2y equal to 6. So negative 4 times 0 plus 2 times 3 equal to 6. 0 plus 6 equal to 6. 6 equal to 6. And that is also true. The solution is the ordered pair 0, 3. So if we take a look at the graphs of these two equations, they intersect at the point 0, 3, which is the y-intercept for both of these lines. In the examples today, when we added the two equations together, one variable was eliminated. So in this example, the x variable was eliminated. That is because the equations that I used, for one variable, the coefficients were opposite each other. So in this case, we have coefficient of 4 and a coefficient of negative 4. Those are additive inverses. So it's going to result in 0. This was why we were able to skip step 2. But it's not a normal scenario. Typically, we have to modify one or both of the equations in order to eliminate a variable by addition. And we'll discuss how to do that in the next lesson. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So both of our equations are already in standard form. So for today, we're just going to add these two equations. We end up with 7x plus 0 equal to 21. Our y term has been eliminated. When we solve the equation 7x equal to 21, we end up with an x value of 3. We can plug this into either of these two equations. I chose the first equation. Solving for y, we end up with y equal to negative 1, resulting in a solution of the ordered pair 3, negative 1. With this second problem, the first equation is in standard form, but the second equation, our y variable term, is first. So the first step was to rewrite this second equation as negative 2x plus 5y equal to 8. And then we're going to add these two equations. When we do add them, we have 2x plus a negative 2x. So our x variable will disappear. We end up with 8y equal to negative 16. Solving this equation, we get y equal to negative 2. Substituting this value of y into either of these equations, can I pick the first equation again? We end up with x equal to negative 9 and a solution of negative 9, negative 2. Drop any questions you have in the comments. Continue practicing solving systems of linear equations by elimination, and I'll see you in the next video.